Okay, in this video, I want to show you a problem-solving technique involving two sample hypothesis tests. Let's go ahead and look at an example problem here. We have a commercial bank and a trust company. The commercial bank and trust company is studying the use of the automatic teller machines, ATMs of course. Of particular interest is whether young adults under 25 years of age use machines more than senior citizens. So when I start thinking about samples and my alternative hypothesis, I would say mean, or the mu I should say, mu mu younger is greater than mu over 60. So we'll get to that when we start talking about the solution technique. To investigate this further 60 samples of customers under 25 years of age and customers over 60 years of age were selected. The number of ATM transactions last month was determined for each selected individual, and the results are shown below. At a 1% significance level, can bank management conclude that younger customers use the ATMs more than their over 60 counterpart? Assume that the population variances are equal. So that's a big assumption. That tells us exactly what test to conduct. And also assume that the distributions are normal. What is the p-value? Let's go ahead and take a look at this solution. Okay, we have our data in the spreadsheet here. We have the column of under 25 and column for over 25. There's no indication at all that this would be a paired test. Obviously, you can't be under 25 and over 60 at the same time. There's no person that relates to this data or anything like that. So we are going to assume that this is, in fact, independent of each other. There's 25-year-olders or less that were surveyed, and then at the same time, basically, of this study, over 60-year-old people were surveyed. Let's go ahead and document some of the things we know. We know that alpha is 0.01, and the keyword is here, more. So the keyword is more, and that's going to dictate the hypothesis statement. So this implies more is a right-tailed test. Okay, so let's apply a little formatting. Keep this spreadsheet looking sharp. Okay, so we have a right-tailed test. We definitely have a situation where it's a two sample. Let's go ahead and look at our formula. So once we open up our formula sheet, we have a case where we can narrow down what the hypothesis looks like. Looks like hypothesis null is mu1 is less than or equal to mu2. Alternative mu1 is greater than mu2. And of course we can rewrite that. Let's go ahead and take this picture while we're here and place it in our spreadsheet for the analysis, just to remind us what's going on. The null and alternative can be written now. Since we've decided on a right-tailed test, we know that the inequality is going to be a greater than. Okay, so we want to know if under 25, so mu under 25 is greater than mu over 60. Okay, that way our keyword matches up with our statements, our hypothesis statements, and we're good to go. Now let's write it, our null, mu 25 under 25 is less than or equal to mu over 60. And we have that desired format. We can also, of course, write this in a slightly different format. We have or. We can say mu under 25 less than, minus mu over 60 is less than or equal to 0. Likewise, mu under 25 minus mu over 60 is greater than 0. So either way you want to write that, that is absolutely fine. Let's go ahead and go to the formula sheet and look at what test we should run. Let's go ahead and look at both trees. Are the samples independent? Yes, they are. Population variance is known. Well, we don't know them, but in the next part of the question, variation is equal, and that is yes. So we're dealing with type C here. Type C, if we were to calculate it manually, would be here. And again, that's a little bit of a nightmare to calculate manually. Luckily, we do in fact have our decision tree for the data analysis tool pack, and it's going to yield similar results. Is it paired? No. Is the population variance known, or both samples have sample size greater than 30? Well, that's no too. Is population variance unknown? Well, that's true. But yes, they are assumed to be equal. So we are going to apply the t-test to sample assuming equal variances. Let's go ahead and do that. Let's go ahead into our data analysis tool pack. We're going to assume equal variance, which is the second option. Let's hit OK. Our range 1 is under 25. Going left to right, that's what appears here first. And our alternative statement, our second range is over 60. Hypothesized difference is 0. We do have labels. We're updating the alpha. And our output can be here. Let's go ahead and generate that report. We are talking about a right-tailed, so we can ignore the two-tailed results altogether. Let's go ahead and auto-expand this so we know what we're dealing with. This is a right-tailed test. We'd expect both the test statistic and test critical to be positive. That's in fact what we do have. We can look at the test statistic and know right from just the table that we're in the rejection region. But always a good idea to graph this.